We are in a new section. We are in section 6.5, and this is called Functions with Radicals. So, we have an equation that is y equals the square root of x, and its graph is going to look like this. So it's more than likely in the Hawks system, it's going to ask you to choose the graph that's correct, and this would be the correct graph for this equation. If you had y equals the cube root of x, then your graph is going to look like y is getting positive as x is getting bigger. So you're going to have it where it's going to go. Because if you remember from last time, square roots or even roots only have positive answers. So you're not going to have any negative or anything down on this side. So that's why it's going that way. Odd roots will take care of your negatives. So that's why you have negatives going this direction and positives going that direction. Now if you get y equals a negative square root of x, then that's where your graph is going, instead of being over the graph, it's going to be below the graph. Or below the x-axis, I mean. Now we have y equals a positive. Since it's positive here, this means it's going to be above the x-axis. Now if you notice, our variable here is x and it's negative. If this variable is positive, under the radical, then your graph is going to go to the right. If it is negative, like this one is, under the radical, then it's going to go to the left. Like on our number line, if it's positive, positive goes positive on the number line. Negative goes negative on the number line. Same way with this. If inside or underneath the radical sign, if it's negative, it's going to go negative. It's going to go backwards. If it's positive, it's going to go positive. If outside, if it's positive, it's going to be above the x-axis. If outside it's negative, it's going to be below the x-axis. So let's put what we just learned into practice with this equation. We have y equals negative x minus 3. So looking at this, we know that it's negative, so it's going to be below the x-axis. This x here is positive, so it's going to go to the right. And since it's going to go to the right, but we have to accommodate this part over here, but it's going to go below the x-axis. So, then we have this here, x minus 3. If we set it equal to 0, we know that if we add 3 to both sides, x is going to be 3. So on our graph that we're using, we went to the positive 3. Right here is where we're going to start. And we knew that x was positive, so it's going to go to the right. And since the negative is on the outside over here, it's going to go below and to the right. A little tip that I can give you is that saves you from having to do this part of it, setting it equal to 0, is that if it's really if a number is really closely associated with the x, then you're going to go the opposite direction. It says negative here, but you're going to go positive. And as you can see here on our number line, we did go positive 3. Let's try another one. We've got y equals a negative x minus 2. Okay, so here we know it's going to be, is it going to go right or is it going to go left? It's going to go left. So it's going to open to the left. Now, this is tricky because there's a negative here. So we might as well go ahead and set that equal to 0. If you add the x, you're going to get x equals negative 2. So on our graph, we are going to go to the negative 2, and that's our starting point. We know we're going to open to the left. We're going to go that way. And the negative over here shows that it's going to be below the axis, x-axis. So we're going to go, it's going to be below, and it's going to open to the left. So that's the graph that you want to choose. These are tricky, but once you do enough of them, you get the hang of them and which direction you're wanting to go. Excuse me. What does the graph of y equals x minus 2 look like? Okay, here's a graph. We know right here, if we set this equal to 0, x is going to be 2. So we're going to go to 2. Is x positive or negative? Right here. It is positive, so it's going to open to the right. We're going to go positive. And here is going to tell us, are we above the graph or below the graph? Since it's positive, we're going to be above. So we're going to go to the right, open it above. Now we're going to have a problem that looks just a little bit different. We have x minus 2, and they want to know what the domain is for this number. Now, anytime that it talks about finding the domain, they really want you to say, what are all the values that x can be that will make this a true statement, especially if it's an equation. But since we just have this, we know that the cube root will take care of any negatives on the inside. So we don't really have to worry about it. It could be, and in fact it is, all real numbers because we have a cubed root, an odd root, right here. So the graph of this equation is, we know that we've moved to the right 2. So that's the point it's going to go through. And it's going to go, it's positive here and positive here, so it's going to go up this way, but it's also going to go down here like that. Because we can have the negative numbers in this one. So if we write this in interval notation, our domain is going to look like this. Negative infinity to positive infinity. Because it's going to keep going in both directions. Now, f of x, this just means we have the function, and it's the cubed root negative 3x plus 2.7. And we want to write the domain in interval notation. So looking at this, we could set this equal to 0 and find our points. and like we did the one above. But really, we need to look at this first. Is that odd or even? Of course, this is odd. So just like the problem above it, odd incorporates the negative as well as the positive. So our domain here is going to be the same as the one above. It is going to be all real numbers, negative infinity to positive infinity. The only time we get into trouble is if we have even roots, because we can't have negative numbers and even roots. Let's work this problem. We have f of x equals the cube root of 4x plus 2, and they're giving us that f of x is 11.5. So we're going to take this value right here for 11.5 and we're going to plug it in for our x. And then use your calculator if you need to. Actually, you're going to need to, because it's going to take too long to try to do this in your head or on paper. So you plug in, we have the cube root of 4 times 11.5 plus 2. And that's going to give you the cube root of 48. And if you round to 4 places, you're going to get a decimal that is 3.6342. So pay really, really close attention to the instructions in your lessons and do what they're asking you to do so that you can avoid simple errors. Okay, now we have this problem. F of x equals the cube root of 2x plus 4. They want us to find 4 points and write them in ordered pairs. Okay, so we're going to have 1 point, another point, and then another point. Now, the trick to these is looking at the index. If it's even, we're going to have a positive number inside here. But it's odd. So we can plug in any number we want to. We could plug in 0 for x, 1 for x, 2 for x, and 3 for x. So if we do that, if we plug in 0, we're going to end up getting the cubed root of 4 for that one, which we won't be able to pull anything out, because 4 divided by 2 is 2, and you need 3 2's in order to pull something out. So and you can leave your answer in radical notation. So you have, that would be the first point. 0 comma the cube root of 4. Then if you plug in 1, over here we have 2 times 1 plus 4 cube root, which is 6 cube root. So, and 6 times 3 is 2. That we don't have enough to pull anything out. So this answer is 1. X is 1. When x is 1, our y is going to be the cubed root of 6. My pen's not fine enough for you to see detail here. Number 2, go ahead and plug the 2 in. 2 times 2 plus 4. 2 times 2 is 4, plus 4 is 8. If you take the cube root of 8, you're going to get, we have a pair, which we have 3 2's, so you get 2 2 is the answer for that one. Anytime you see where they want ordered pairs and it's an odd root, you can just stick any number you want to and get your answer. And for our final one, number 3, we've got 2 times 3 plus 4, and we're going to take the cube root of that, and that is 6 plus 4, which is 10. 10 only gives out a 5 and a 2, so we have the, whoops, I wrote that wrong. We're going to have the cube root of 10. And that's all the 4 points. I mean, you could seriously put in any number you wanted to and get, just as long as you did the math right, you would have a correct answer. Especially if you have an odd root. Even roots, you have to make sure this, whatever this is above a negative number. Again. Alright. Let's try this one. F of x is equal to square root of 5x minus 3. And they gave us the information, f of x is 5. So f of x, our x value is 5, we're going to plug it in here. They want us to use radical notation. So anything radical notation means you're going to have a radical in your answer. So we have 5 times 5 minus 3, and we want the square root of that. So we have 25 minus 3, which is 22. And 22, let's see, we have 2 and 11, and those are both prime numbers. So we can't, well, 11 is prime, so we can't take any more out. So our answer in this is radical square root of 22. Next one is h of x equals cubed root of negative 3x minus 5. And they want us to find 4 points. Can we plug in anything we want to? Our index is odd, so yes we can. If it was even, then we would have to check to make sure if it was even. On this one, if we plug in 0, we're going to get here, let me write these out. 1, we go to 2, and then we go to 3. Alright, we're going to plug all those numbers in. So we have, if we plug in 0 here, we're going to get negative cubed root is 5. Well, we know that if you take a negative times a negative times a negative, you're going to get a negative. So that's going to be a negative inside here. And we can't, all there is a 5 there. So it's going to be negative square root of 5 for the answer on that one. This one, when you plug a 1 in, you get negative 3 times 1 minus 5. And the cube root. So we have negative 3 minus 5 is a negative 8. The cube root of negative 8 is negative 2 times negative 2 times negative 2. So there we go. Again, because it's odd, it pulls out the negatives. Now we have 2. We have the cubed root of negative 3 times 2 minus 5. That is negative 6. Negative 3 times 2 is negative 6 minus 5 is a negative 11. Again, negative will come out because it's odd. Cubed root of 11. I missed my cube root. Again, that's a really common error to forget to write those in there, so please be careful. And then for our last one, we're going to plug in a 3. So we're going to have negative 3 times 3 minus 5 to the cubed root. So we've got negative 9 minus 5, which is negative 14. The negative will come out. And I don't believe we've got 14 has 2 and 7. So there we go. Cube root of 14 is the answer for that one. And that's our 4 points that you write in. Just put them in there, and that's what you'll have. I mean, you could have chose any points. You could have put a negative 1 in there, or a negative 2, and a negative 3. And you would have got, your answers would have been a little bit different, but they still would have been correct. Now, g of x equals the cubed root of 7x plus 2. When g is 10, they want it in radical form. Okay, this is our x value, so we're just going to put x in there. And we're going to solve. So we have 70 plus 2. So we're going to have the cubed root of 72. Can we pull anything out? We can't just divide these because remember, we have to have it the prime numbers. So 2 will come out of 72, giving us 36, 2 and 18, 2 and 9, and then 9 is 3 and 3. Index is 3, so we want groups of 3. A 2 will come out, but a 3 stays inside. So we have 2 cubed root of 9. And that would be our answer because it is in radical form. Okay. Now we're going to go back to some stuff we did. Earlier we did cubed roots, but now let's do a couple of squared roots. Trying to find the graphs of squared roots. So, looking here, we know it's going to be above the graph, the x-axis, I mean. And here is positive, so it's going to go positive. It's going to go to the right. And to find out where it's going to be, we're going to put x plus 4 equals 0, so x equals a negative 4. So on our graph, we're going to go to negative 4 on our x-axis, and we know that it's going to be above the graph according to this, and it's going to go positive. So that's our graph. But how would we list our domain in interval notation? If you look, domain means our x's. So what is the value of our x's? We have no x's out here, and you always start in the negative infinity. And we're going to come and our graph starts at negative 4. So it will include negative 4 and it will continue forever in positive infinity. So that is what the domain is for that particular equation. Okay, the last problem we're going to look at is another similar one. We have y equals the square root of negative x plus 1. So here's our graph. We want to know where we're going to start, so we have to set that equal to 0. If we add our x to both sides, we get x equals 1. So we're going to go to 1 to start with. Now let's look. Our x is negative, so we know we're going to go negative. So it's going to go this way. Here, though, is it going to be above or below the line? Since it's positive, we're going to be above the x-axis. So where it's going to be above, and it's going to go to the negative. So it's going to go this way. Now, how do we write that in interval notation? Our domain, for our domain. We always start our domain at our negative infinity, and it's going into negative infinity. So we're going to start with negative infinity. And as we come along our graph, it stops at positive 1. And it does include positive 1. So that's our answer.